Thank you all for coming today. I appreciate the attendance. Lucas, you draw quite an audience, which is great. If somebody could shut those doors, that would be good. We'll keep the coffee talk out. We appreciate everybody coming to the first concurrent session. This first session is going to be on chemical agent decontamination, and we had quite the turnout for that topic, so this will be the first of two sessions. I just want to remind everybody, we will have presentations. We're going to have a series of 4 presentations, starting with Dr. Audiens and Dr. Seri. We will have about 20-ish, 25 minutes, hopefully leave a minute or so for questions at the end. This is being broadcast virtually as well, so we will try to entertain some virtual questions if we have time. So once we finished, if you could step to the mic and ask your question if we have time. We'll try to keep us on session here. But the first session is going to be on full-scale testing of a simulated chemical warfare agent contamination response. Dr. Lucas Audiens is going to be speaking, and he's brought a special guest, Dr. Shannon Seri, with him. Shannon's going to be interpreting because Lucas has a Dutch accent. So we just wanted to make sure that everybody could understand very well. So I'm not going to give you too much on their background, so we can go ahead and get started. But Lucas obviously has a PhD, is a research physical scientist with EPA's Office of Research and Development, Center for Environmental Solutions of Emergency Response. As a colleague of mine, Shannon is in the Office of Emergency Management, Office of Land and Emergency Management, Consequence Management Advisory Team. They will be talking today about the full-scale simulation. So let me give it up to Lucas and Shannon.
All right, good morning, everybody. Thank you for the kind introduction, John. So I'm talking here about what we have called OTECRA, and it's the operational testing and an evaluation of chemical remediation activities. So when you hear the acronym OTECRA, it's not a medication, it's not a former dictator in the Central America. It's an acronym that was fully used. There are a couple of authors on here, and I should recognize that that is actually only a limited number. There were also people who are doing a lot of work behind the scenes that are not really recognized here. And there was a lot of people who were clearly at the site itself. So what was the purpose of this specific full-scale exercise? First of all, as Dr. Sean Ryan already alluded to, this was the first time that EPA delved into consequence management remediation at the full scale following a chemical incident. So the intent was essentially to see where are we as EPA in remediating, where are we in, do we have the response capabilities to do this following a chemical incident? We had done it already multiple times for a biological incident. This was the first time for a chemical incident. So kind of the sub line under it is essentially, can we take what we have learned at the bench scale, as example, as shown in those pictures there, as somebody wiping at a small coupon, and take that into the field as illustrated, maybe sampling the rails in an underground transportation hub? Or can we do decon at the small scale, very small coupons, limited amounts applied or high amounts applied? And can we do that in the full scale as illustrated in this demonstration in an underground venue? So we had a lot of objectives. Maybe I'm not going through all 8 of them or all 7 here, but clearly they focused on developing sampling strategies, determining whether our methods on sampling, both wipe sampling as well as a more novel wet vacuum sampling, were actually working. We also incorporated a lot of data management procedures that were initially already included in the biological full-scale exercises, but were also tested here in an indoor environment, which is completely different from an outdoors environment. We conducted clearly decontamination approaches and wanted to test indeed whether they were actually held through from bench scale up to the full scale. And then important in that is also collect all kind of informational, operational information. It's one thing of just doing as bench scale research. If you do it at full scale, you get people dressing out in PPE and getting information on how feasible does it work and what's the cost on it. Second to last one is a critical thing, waste management. We always think about waste management as the last thing. You always have to think about it at the beginning. As soon as you step into a site, you're already creating waste because you're putting on a pair of gloves. Well, the gloves are part of the waste stream. So if you don't have a plan for waste management, you're in trouble. Last but not least is also that we extensively used the CWA decontamination line protocol. I will not be going into that in this presentation. There is a poster actually about that tomorrow afternoon or tomorrow morning. I strongly encourage everybody to take a look at that because they did a tremendous job on not only putting it together, getting people safe out of the contaminated area and make them all being clean when they came out, but also did a lot of effort in illustrating how this worked, the whole concept. So the approach was that we identified, let me see, Shannon, are you going here? Oh, good, right, one more. All right, the approach was essentially to identify a site where we're gonna do that. So we went through a long process identifying sites. We settled on a Muscatatuck Urban Training Center in Indiana. And the second thing that we had to identify was kind of what simulant we were using. We were not planning on using a true chemical warfare agent. That would be almost impossible and extremely expensive. So we had to settle on a simulation. Simulant, we ended up using malathion, which is an organophosphate pesticide with a similar persistence or maybe even more as VX. So there's a connection there to the CWA. We also want to make sure that we wanted to use a realistic environment. So we created office rooms and then a studio apartment that we outfitted with the attributes that you would typically find in that, tables, chairs, computer equipment and whatnot. Last one that we want to also include is, and the acronym was already mentioned earlier, the PHYLLIS. So now remember that it is the portable high throughput integrated laboratory identification system. They were on site doing the actual analysis of the sample. So imagine that you have the capability just to collect the sample, send it to the lab, get it analyzed, and the next morning, or if you really push maybe in the evening, you already know what you were sampling. Wouldn't that be great on the biological side? Okay. All right. So they were extremely helpful in doing this, making this work. Shannon, I'll hand it over to you.
So data management plays a huge role in any response. There's a lot of information that's tied to the samples that are collected. And we had a fairly small sample set, but there's still a lot of information that goes along with that sample as it transfers to the process. Samples and data are connected. You can't have samples without data and vice versa. So we started, Tim and his team started, they designed the sampling plan, and that sampling plan followed all the way through the entire exercise. And it was a holistic data management process, and you'll see some of those steps we took here in the slide after this. This allowed for a dynamic system that could not only guide the samplers, but follow the data and the samples through the entire analysis process. A sampling, the left side of that photo there, the slide up there, you can see the system that was used to guide the sampler to the specific location. And a QR code was used to scan once they got to that location. That QR code was a unique code that followed that sample all the way through the process, from the time of collection to the time of analysis. This data was continuously streamed from the mini iPad that they used. The continuous streaming helped in case the iPad was damaged, whether it was through the Decon process or something else happened. It was streamed through this mobile network that was set up in that middle picture. In the back of that Expedition was a mobile Wi-Fi system, a plumb case, so that they can continuous connection to the data stream. It was also useful to see whether all of the samples have been collected. There was a data management dashboard that the data management team, Tim and Jordan and so forth, could watch and say, hey, sample team 3, you've missed a sample. Please go back and collect it. Or they said, oh, we did collect it. There's something with your data transmission. Fix it, Tim. That's a joke. The electronic DDD, electronic data deliverable, followed the sample through the entire system and also helped with the chain of custody. So at the end of the day, once the samples were collected, went through the Decon line and processed, you could follow the process by scanning that code ultimately to where it was analyzed at the lab. As Lucas mentioned, he did a lot of research looking at a surrogate that could be used. We settled on malathion, technical grade, and the goal was contamination of 1 gram per square meter. And this was laid down using 25 microlittle droplets over a square foot template. And then we also had reference material coupons associated with the different surfaces that Lucas mentioned. We had the studio set up as well as the business set up in there, but we also had the RMCs, which were just stainless steel coupons that were also dosed with the malathion so we could get the exact amount that we put down. A targeted and judgmental sampling plan was developed for the different rooms in the building. It was roughly 2,000 square foot building, 2 separate sides. There were approximately 40 pre-decon and 40 post-decon samples that were collected. If we had used the visual sampling plan, it would have been about the same number of samples with a 95% confidence. We also sampled the waste that was coming off the decontamination line, as well as any of the liquid waste that was collected following the decontamination. The sampling methods that were used, the traditional wipe sampling method, which is the gauze pad with hexane, was used over a 12 by 12 area, so 1 square foot. And then we also tested and evaluated an innovative sampling method that was developed by Stuart Willison of ORD, which covers a 3 by 3 area, so 9 times the surface area they got from the wipe sample. So it's more of a composite sampling. And this was its first use at field scale. And what it utilizes is a surfactant using a household wet vac. As Lucas mentioned, the Phyllis unit was on site, and I didn't spell out the acronym. I can say it without reading it. The Portable High Throughput Integrated Laboratory Identification System. So I'm going to be testing people at the end of this, so make sure you have it written down. It was nice to have it on site. It not only eliminated the need to transport samples, which is very, very difficult given the contamination, but we got a quick turnaround time. We had 1 to 2 day turnaround time by walking the samples over to the Phyllis unit and having them analyzed. It was analyzed by a GCMS for not only the malathion, but also the metabolite naloxone. Wet vac samples that were collected were sent to an external lab, and these were water-based samples, and after solvent exchange, they were also analyzed by GCMS. And then the RMCs were transported back to our lab and RTP for analysis by GCMS.
All right, so let's talk a little bit about the results that we got prior to the decontamination. So first of all, we wanted to identify where we were successful in contaminating the various objects that we had in the building. And maybe I should point out, we did not go around, as you saw, with a spray and completely slime the whole interior. We had discrete sample or a discrete application of the contaminant of choice here, malathion. So what we found was that after analysis, this was done by the lab in the EPA, that we were successful in applying the malathion in a concise manner, in which we identified that we were almost 96% was always recovered from these reference material coupons on both days. And important to see also that although we applied on, call it day 0, the next day when we were actually doing the sampling, we got the same amount of malathion back, which is not too surprising. Malathion is highly persistent, but it was good to verify that we're not losing malathion before we starting actually the decontamination process. So these are the results for prior to decontamination. And there are a lot of graphs, or a lot of bars in here, but what you see on the horizontal axis are the various material types that were involved. And they range from painted drywall to glass, a table that was sampled multiple times, flooring materials, a PC case, a mirror, and so on. And on the vertical axis, you see the amount that was recovered. And there's kind of two groups of materials detected there. The non-porous materials give you good high recoveries in this case, the 70 to 80 micrograms per square centimeters, which is roughly 55 to 65% for the wipe sampling. That is the one group. Then there is another group which was sampled quite frequently as well, and that were the painted drywall and the concrete, or actually painted concrete, and we got very poor recoveries. And they were actually fairly consistent in that respect to what we have seen in the bench scale due to absorption of the chemical into the material itself. The one thing that maybe stands out as a little bit odd one is that the mirror that was placed vertically got a low or a small amount or lower amount recovered, but that was likely due to the movement of malathion slowly dripping down. So by the time that the sampling team would have come in, they did not actually collect all the malathion that had already dripped down below the surf that was collected. Thank you. So the interesting part is actually, and that's I think a very positive sign from this specific exercise, is that when you look at all these sampling teams that were collecting the samples, they're all individuals that were trained essentially prior to coming to the site or at the site itself. on how to properly wipe sample the surfaces. And if you look at how what the standard deviation or the relative standard deviation was when you compared, we pulled all the materials together, you see that everything was highly reproducible. So although you have different people to work with, this sampling method was developed with Stuart Wilson's input, is very robust and can be used indeed for this type of chemical. So the other one is that wet vacuum sampling. Well, there the results are not as great as we may have hoped for. The recoveries were more in the 17% range, or maybe at best 20%, which is clearly not as good as the wipe sampling method. And we also saw a high variability in the results itself. One of the reasons why it probably didn't work well, and I should point out that the wetting solvent for this wetting vacuum sample was water and soap combination. It still has to deal with the solubility of the malathion in this specific solvent, and that probably led to a lower recovery. The other thing that's going to happen, of course, is that when you have a flooring system that has been put together and there are cracks in it, clearly we're not the experts in putting things together on a very short time scale. Some of the liquid actually may have seeped into the cracks in between, and you cannot sample it after that. Don't take that low recovery now to Stuart and say, why is it not working? I was the one actually who developed it, so you can blame me for why it is not working. Shannon, you'll take over about decontamination.
So you heard it mentioned earlier, we started at the bench scale, moved to the pilot scale, and then ultimately the field scale. So we decided on 2 different technologies that showed promise in the lab, and we tested these at the field scale. The 2 different Decon technologies we used were Decon 7 activated peroxide that was developed by Mark Tucker when he was at Sandia, as well as undiluted bleach, just straight household bleach. And the amounts that we used were derived from previous work that had been done on surface Decon. That was BOAT in 2011. And then the OTD exercise in 2016, which is a roughly 16 gallons per every 1,000 square foot of the building. Preparation of Decon 7 required mixing up the 3 different components, the surfactant, the peroxide, as well as the activator. This was mixed in the blue drums you see there, the 55-gallon drums, and then that was transferred into a 26-gallon commercial off-the-shelf sprayer. The commercial off-the-shelf sprayer was from Northern Tool and Equipment. The only modifications we made were to extend the line from the sampler to about 65 or 70 feet so they could snake that through the window to the Decon teams. Bleach was applied as received, the 7.5% hypochlorite concentration, no dilution or acidification of the bleach itself. And PPE, when we were mixing up the Decon 7, we were in a full APR with the PAPR. When we were pouring in the bleach into the tank, we just used a face shield. The decontamination was applied. Is this the video or is it the next one? We'll start the video while I talk. We had 2 different teams on each end of the building. The teams were comprised of 2 individuals, one to monitor the line, the other to spray. We did not spray the ceiling, only the walls down to the floor. Approximately 90 gallons was applied of each of the products, 90 gallons of Decon 7 during round 1, and then 90 gallons of the bleach during round 2. Application time was about 2 hours per team. The residual Decon 7, when we went in there, it's designed to foam. It was, people laugh. It wasn't funny to me and Lucas. We're still very traumatized. When you get in there with a plan and the plan doesn't work, then you have to improvise, and that's what field testing is about. The wet vac did not work. We ended up using a broom and a dustpan and trash liner bags. Had we allowed it to collapse like it's designed to do and get the extra contact time, we could have come in the next day and vacuumed it up, but we were a quick turnaround time. So we had to scoop it up. The bleach, when we went in there, it was all dissipated. There was nothing to really vacuum up. We did have air movement through there using negative air machines to move a lot of air through the building to make sure it dried along with floor fans so that they come and do the sampling the next day. The decontaminant was applied until the entire amount was done, and then like I said, we came in and cleaned it up, whatever we could.
All right. This is a little tricky slide because I'm not a toxicologist, but the take-home message here is essentially that prior to the decontamination, we established what our cleanup values would be for this specific incident. And that's based on a number of assumptions in the calculations, non-cancer surface screening levels, using indoor non-porous materials, and based on an adult. April Luke, who is here, actually will be talking about that on Thursday as well as part of her presentation. So you can ask those kind of intelligence questions to her. I will not give you an answer here. So these are results that we saw after either decontamination with Decon 7 on the left side, and on the right side, the bleach decontamination. And on the vertical axis, you see each time the mass recovered. Initially, we started in the 100 micrograms. We're now in the single digit of micrograms recovered. And the two dashed lines that you see are these clearance goal levels based on how comfortable you want to be. You want to be extremely conservative or not. And what you can see clearly here is that the materials that were difficult to decontaminate were those porous materials. Again, no surprise there. So one of the take-home messages is likely that you probably will not be able to decon these in a real scenario either, because you will always find residual decontaminants, contamination on those type of surfaces. Everything else actually made it all the way to the most conservative level. And I apologize, we need to speed up because we're running out of time. Important, clearly, waste management. All waste items, including the ones that we are contaminated and did not meet the criteria, were collected. Also the PPE from the Decon line, liquid waste was collected and was stored, or was actually ended up, not a liquid waste, but solid waste ended up in a 30 cubic yard roll-off box. The liquid waste ended in multiple 50-gallon drums and were handled accordingly. Waste was managed and accepted by 2 companies in Indiana and Ohio. The companies actually had specific requirements about the waste itself. They wanted to know how it was generated. They wanted to know if there was any of, in this case, malathion remaining in there, needed safety data sheets, no surprise about that, and specific waste profiles. That text in the bottom clearly would remind everybody that this may work indeed for malathion in this case, but if this was a true CWA incident, it would have been more complicated. So in summary, we demonstrated, hopefully, and there's clearly much more to talk about. We did not delve into specific about the cost element and others, and more details about data management, but we think we did a successful job in demonstrating that we are capable of decontaminating and remediating an indoor material, an indoor environment. Both decontaminants that were tested, Decon 7 and bleach, worked equally well. And we found that we were able to return the facility back to Muscatatuck Urban Training Center at the end, because we did a third round we did not show here of additional testing for malathion, did not find anything in the environment in the interior. This is one group that participated. On the right are all the first names. You see there are a lot of people there, and it takes a village almost to this type of exercise. That's why we cannot do them every year. But this was an extremely helpful event, and we thank everybody for participating. And with that, I'll be happy to answer any questions on the minus 30 seconds remaining.
Thank you, Lucas and Shannon. Do we have time for any questions? Dana.
So the question was the fumigant that was used. We were not using a fumigant. We're using Decon 7, which is a hydrogen peroxide, activated hydrogen peroxide product. And we used full strength bleach, 7.5 sodium hypochlorite, straight out of a bottle. Yes.
Repeat the question.
Yeah. So the question is whether we were looking into vapor sampling. The answer is that we did not do that directly as part of the decontamination procedure itself. However, we did use it as part of our Decon line procedure, where we use an AP4C, A2, what is the acronym? A42C. Yeah, that's doing it. Okay. Where you can detect malathion in the vapor phase, and you essentially volatilize the malathion that you collect from a sample.
Okay. Last question. No questions. Okay. All right, let's cut it off because they passed the baton about 18 times between the two. We lost about 3 minutes, so we'll have to move on. Thank you again, Lucas and Shannon.